Have you ever really looked at your computer screen and wondered why it looks the way it does? We usually just think of it as, design, but what if it's way more than that? What if it's a security system hiding in plain sight? Let's dive in.
So let me ask you something straight up. Is your operating system lying to you? Think about it. Could a malicious program be showing you a fake login screen or a fake error message, tricking you into giving up your data while the real system has no idea?
It's a pretty scary thought. But in ChromeOS? Well, the answer is built right into the design itself. Just look at this network health screen. Every single piece of this interface, from the specific color of those check marks to the font in the menus, is actually a silent guardian working to prove that what you're seeing is real and that your system is secure.
Okay, so how on earth does this actually work? To figure that out, we need to look way beyond just the pixels and deep into the architecture of the user interface itself.
So, the core idea, and this comes straight from the technical specification, is something they call a hardened visual layer. The best way to think of it is like a digital watermark that's invisibly baked into every single thing you see on screen. Each element becomes a piece of evidence, a clue, that proves the system is in a legitimate, secure state.
Now, to build a digital fortress like that, you absolutely need a solid blueprint. So let's take a look at the central architecture that makes this entire hardened layer even possible.
What's so cool about this slide is how it lays out the whole battleground. On the left, you've got these really sneaky threats. Malicious shims, for example, are basically imposter elements. Fake buttons or windows designed to float over your real UI to steal your clicks. And on the right, you've got the defense. The whole system is built from a single source of truth to prevent those tiny inconsistencies that attackers just love to exploit. And this single source of truth is an incredibly strict, locked-down pipeline. It all starts with these core configuration files that define every single color, shadow, and font. These are then used to forge one single unified style sheet for the entire OS, and the result is that verifiable, hardened visual layer. There are absolutely no rogue styles or one-off exceptions allowed. Everything has to flow from that original, secure source. And this, right here, this is the whole point. Think of this visual signature as a unique digital fingerprint for the UI. Every button, every menu, every window has this fingerprint burned right into it. So if some malicious program tries to cook up a fake element, it just won't have the right signature. It might look close, but it'll be just a little off. And that tiny difference, that's your first, crucial clue that something is very wrong.
All right, let's see how this actually plays out in the nitty-gritty. How are individual design choices, things as simple as color, turned into these powerful defensive weapons?
Just look at this table. In ChromeOS, a color isn't just a pretty choice, it's a system state variable. That specific red used for an alert, --color alert, is strictly defined as Google Red 600. That's not a suggestion, it's an ironclad rule. Same goes for warnings and positive feedback. So what does this actually mean for security?
Well, it leads to this powerful concept of a forensic indicator. If an alert message shows up in a shade of red that isn't exactly Google Red 600, that little deviation is forensic evidence. It's like a digital smoking gun, a clear signal telling you that the system itself didn't create that element and that something is seriously wrong.
And here it is in action. We've all seen a network error page like this, right? Well, that specific color of red is the verified signal we were just talking about. A phishing attack trying to fake this page would find it nearly impossible to replicate that exact color because it's not just some random hex code. It's a variable that gets generated directly from the system's protected single source of truth. Okay, now let's talk about text. You probably wouldn't think the font you're reading could be a critical security feature, but in ChromeOS, it's actually a powerful lie detector.
The threat here is something called an OCR scrape risk. Basically, a malicious overlay could display text that looks totally normal to you, but is subtly different to a machine. This could trick automated screen reading tools into scraping your sensitive data, and you'd never even know it was happening.
The defense is a super rigid, non-negotiable typography scale. As you can see, Google Sans is for display text, Roboto is for body text. And those interactable elements like buttons must use a specific font weight. So what happens if you see a button with the wrong font? Well, it's another one of those forensic indicators, a dead giveaway that you're looking at a fake.
Okay, so we've covered color and we've covered fonts. But believe it or not, the system goes even deeper. The final layer of evidence is hiding in plain sight, the shadows and depth of the user interface. The specification calls this tactile forensics, and isn't that a fantastic term? The whole idea is to make the UI feel physically real and consistent through the standardized use of shadows. A fake dialog box just slapped on top of the real UI would have the wrong shadow and it would look totally out of place, like a bad cut and paste job. It would instantly shatter that tactile physical illusion of authenticity. And just like everything else, these shadows are not random. Each elevation level has a precisely defined set of shadow values, broken down into a key directional shadow and a soft ambient one. For a high-priority system dialog to be real, it absolutely must use the elevation 5 shadow. So any other shadow proves, you guessed it, it proves it's an imposter.
Now, this is a brilliant little detail. When you click and drag a window, ChromeOS intentionally changes its visual state to dropped elevation, which basically removes its shadow and makes it look flat against the screen. This is a critical visual confirmation. That brief flattening proves that the real operating system is in control of that object, not some malicious shim trying to hijack your clicks. So clever.
So when you add all of these layers together, the color, the typography, and the shadows, the user interface itself becomes the guard. It's this silent sentinel, constantly watching over your system.
And these aren't just design guidelines, they are mandatory security implementations. The system forbids any code from hiding security banners. It requires that a visible blue focus ring always shows you what you've selected, so malware can't just silently track your clicks. And even things like Mojo bootstrap and consistency ensure that the way fonts are loaded can't be hijacked to create a rogue network connection. Every single rule is there to turn the UI into a consistent, verifiable, and trustworthy guardian. Pretty cool, right?
So in the end, that polished interface you use every day is so much more than just a pretty face. It is the visual proof of your system's hardware-level integrity. Every single pixel is a promise that what you're seeing is real.
It really makes you wonder, doesn't it? What other secrets, what other incredible layers of defense are hiding in the technology you use every single day?